Hello, my name is Teju Prasad. I'm a senior developer here at Small Planet, and this presentation will be on React Native. What it is, in a nutshell, is a JavaScript-based cross-platform engine for developing iOS and Android. And this is a platform that's been built by Facebook slash Instagram. And here I've just given a small sampling of the applications that currently use React Native, Facebook and Instagram, obviously. Airbnb and Walmart are two big ones, as well as an art service called Artsy, and then Bloomberg. They've actually integrated React Native into their tech stack. One thing which I'll get into a little bit later is that React Native can actually you can vary the amount in which you integrate React Native into your existing project. So, for example, Airbnb in their integration kind of dealt with this because they had an existing app and they were integrating React Native slowly, which is something that React Native affords. So it's not an all or none decision. Here are some sample screenshots from one of the tutorial apps, both iOS and Android. So you can see here that the UI that's generated from a React Native app is actually quite similar. So the overall workflow is essentially you have a React Native sort of background, and you have your app UI, which is actually loading up native UI components. And this is all handled through what they call the asynchronous bridge, which takes the JavaScript that you write in React Native and processes that and sends it over to your Xcode project or the Android Studio project to generate those native UI components to give you that high performance. So this is the project structure of any React Native app. The things to really take note of here is that when you create a React Native app, it generates both an independent iOS and Android project, both an Xcode and Android Studio project, and two separate entry point files for which that you essentially start your apps on the iOS and Android side. Now, what generally happens is you create sort of a main source file that both the Android and the iOS file point to. That way you keep your UI tied together when developing both apps. Okay, so the basic building blocks of a React Native app is an element and a component. And loosely, these translate to screens and individual UI elements on the, and I'm going to show you in this case, the iOS side. This is not a full one-to-one correlation, but it's more of a loose comparison in which components you can actually have multiple components per screen. However, a screen is generally going to be a single JavaScript file. So here's an image that illustrates this. Components, in this case, I have two marked by the red line and the green line, and they both fit on one screen. And elements in this case are individual UI elements that exist within a component. So in this case, a label and then a button with a label inside. Okay, so React Native has a very sort of strong delineation between their component types, and one being stateless and the other being a state or having state. So the main difference is that stateless components are kind of considered quote unquote dumb components, and they have no life cycle, meaning that you have no concept of or you have no ability to schedule events when the component is generated or mounted or destroyed or anything like that. And you have no ability to have properties associated with that component that can change over the life cycle of that component. Components with state these are the more, I guess, sophisticated components, and they have lifecycle methods, and it supports the ability to store data associated with the component that you can actually change by taking action or moving off screen or on screen. Okay, so now we get into the operation essentially of React Native in the sense of how are these components built. Components are built using what's called JSX and straight pure JavaScript. JSX is kind of a shorthand for JavaScript, which is written very much in a tag-based HTML style, but essentially every JSX command, it does translate to a JavaScript command underneath it. So here's an example where a text component, a text element is converted into this JavaScript command. And here we have a more fuller JSX in defining an entire component. In this case, it's a view with a text element and 2 buttons. Okay, so React is what's called declarative, meaning that there is a single render method, and within that render method, you will see exactly what's displayed on screen at any point in time. The render method is sort of completely the single point for what is displayed on screen. Now, this is kind of where you relate to your state properties or your component properties, but everything essentially takes place within the render method. Okay, so now we get into the styling side of React Native. React Native uses what are called style sheets, and this is quite similar to the HTML CSS style of styling. And each JavaScript file has its own style section that you modify. So in this case, you can see I've shown you the style block, and then each component element has certain properties that you vary to vary the look and style of what it is that you're building. So when looking at state propagation, the idea here is how do you communicate the app state from one component to the next? And the general approach here is to initialize state at the highest level of the app and then send that downwards through your component hierarchy. In this case, I've chosen a basic sort of chatting app as a instructional app. And this chat app, you have your main screen, and it's kind of split up into 2 different component areas. One is the messaging area. The other one is the text entry area where you're actually typing out your messages. And then your message container area will be further split up into individual messages. Those are going to be separate components. So in this case, you have a bunch of state variables like, for example, how many messages you've received, what your last message is, what's your new message, if you're creating a new message or not, et cetera, et cetera. So all those are defined at the top level, and then you basically pass them down to the components that need it. And that's what this diagram shows. So the problems that occur with this type of state management is that your state update methods can potentially be passed through components that actually have no use for them. So in our case, it's sort of a simple case, but it does illustrate this point in that, for example, the message container doesn't necessarily need to know anything about the actual messages. It's the individual message view that has to present the message. So, but just because of how we've built our hierarchy, the container has to receive that data and then just simply pass it through. So that can get kind of cumbersome when you have an app with a much deeper hierarchy, because you're just sending data to components that really have no need for it. And also you get into some issues when you are trying to do lateral state dependencies, in the sense that if you wanted a sibling view to change another sibling view based on an action taken on it. So for example, let's say I start typing and I want to make a change in my message area for some reason, that's a little bit tricky to do because the flow of information is really one directional. So the solution that is often used with React is something called Redux state management. And this does actually address both of the before mentioned problems. So in our chat messaging app example, what we essentially have is Redux gives us a global state, and each component kind of connects to this global state and peels off the state that it needs. So in our case, our text entry area will only peel off information like current message or am I entering a message or something like that. Our message views will only peel off the messages that it is displaying, that one message that it's displaying. And what happens is the way this global state is updated is that actions are taken on your app in terms of, in this case, you're entering a text message, and those are reduced into state updates. And really the reducers are the objects that contain the business logic. So we kind of get one more added benefit in which all the business logic is co-located in these reducer methods. And the UI and the business logic is actually kept quite separate, which also gives us an added benefit of clarity. So yes, advantages of Redux. We have clearer separation of UI and business, co-location of state updates, and components only really pay attention to what they need to. So another positive function of React is their ability and the amount of foresight that they've put into making sure we can integrate third-party libraries. There are really two main varieties of third-party library integration. One is NPM packages, and these are built by developers, and they're put up on as NPM packages that you can use freely. The others are manually built bridges, and these are more of the custom code things that, say, a particular firm or a particular company would need to build out manually to just service whatever their need is at that point. The manually built bridges does take more time, and it also does take specific domain knowledge of whatever platform it is you're working with. So, for example, an iOS developer would need to be decently familiar with how Xcode works and Objective-C and those sort of things. So here over at Small Planet, we had a library that was used in a particular project called Arbiter, and this particular slide covers how I created the Arbiter library and its use in a iOS Xcode project. And this code covers the JavaScript Android side. Essentially, it's a similar process where you create a native bridge. In terms of what types of data you can send over from the native project to the React Native side, essentially it's sort of like your basic types: string, numbers, booleans, arrays, dictionaries, and methods. And on the Android side, it is the same with the exception of readable array and readable map. These are special types that were created by Facebook for capturing this type of data. I think they had this flexibility because Android is developed in Java and React Native is developed in JavaScript. Okay, and just a couple other observations here. Third-party NPM modules are starting to get a decent amount of variety, for lack of a better word, and this includes things like audio and video and map support, animation support. One thing to take note of is that as you introduce more and more dependencies into your project, it does require you to kind of keep up to date with making sure you have the latest versions and maintaining compatibility with the latest version of React. And in some cases, when you do bring in these libraries, you have to pay attention to certain tweaks you might have to do when submitting the apps actually for production. Okay, so React Native also offers server-side hosting, the ability to host your entire app on a server Microsoft has a product called Code Push that is built specifically for this. Um, some people have done this with simple apps to be able to release updates without going through the app review process. And there's also an interface builder tool that's in a beta phase that allows you to build React Native UI using simple sort of drag and drop type interface builder tools. Performance testing. So the experiment here was to just run a large iteration for loop and then compare the JavaScript React Native implementation versus the actual native implementation, Objective-C and Java in Android case. And here's the data for that. And the next slide I'll be showing you shows you the graph comparison. So we see here that on the Android side, the native implementation was not as fast, but the range of how fast is smaller. So some of this could be tied to the actual use of what JavaScript interpreter is being used in the Apple sort of iOS case versus the Android case. But we see here that yeah, the native implementation certainly is faster by a pretty significant degree. The pros, well, we know it's cross-platform. It's kind of the purpose of React Native. It is declarative style. It does have a faster testing and development style. We have essentially something called hot reloading, which I can actually demonstrate. So we see here in this application, I have the style sheet with respect to these UI components. And we see here, if I just, for example, change the background color and say move it from justified to center, and I'm developing, and all I do is just refresh here, you see that we get the change instantly. So this is, it could be a good benefit for apps that have a large compilation time. You can work through UI tweaks much quicker. We talked about server-side hosting, clear UI and business logic separation. Another point is, in some cases, companies that already have a React / Redux store that's used on their web stack, they can leverage that and they can just have their apps talk to the same database store. And of course, yeah, this again, you can vary the level of usage. So the cons, we have dependencies, as mentioned before, on various modules. That does increase, the risk somewhat, and requires you to maintain, make sure there's compatibility between all your dependencies and the current version of React. It's an uncertain roadmap still, so we all know what happened with Parse. That Facebook can kind of decide to do whatever it wants, and by using React, you're essentially making a bet, that they'll continue with the development. There's a chance for heavy customization if your app tends to use a highly customized library, and it is JavaScript based, so there's certain limitations with processing time and syntax. And finally, so the big question is, React, should we do it? From this small investigation, it basically was determined that React Native is a good choice for simple apps that we don't have a lot of heavy computational processing. React, I feel, is also built for apps where a lot of the resources are stored on separate servers rather than locally, in particular media resources like images and video. If you have an app in which the UI is nearly identical between your iOS and Android iteration, that also is a good choice for React, as it will yield a higher percentage of shared code. And in some cases, it could be a useful tool for prototyping solutions and just building proof of concepts for for various client projects. And that should conclude the presentation. Thanks.